Now let's take a look at practice problem 5-5. 5-5 is, I've included this because it's not quite as straightforward as the previous practice problems. For one thing, there's no dimension on two of these pins, pin E and pin F. You have to figure out where that grid spacing actually should be. And then a second complication is that the 1,500-pound load is at an angle of 60 degrees. Now, MD Solids will not let you insert a force at an angle in truss analysis. So what do? We have to break that 1,500-pound load up into its horizontal and vertical components. So first, let's do that. I have 1,500 pounds at 60 degrees. So this force will be 1,500 times the cosine of 60 degrees. And this force will be 1,500 times the sine of 60 degrees. This number is 750 pounds. This number is 1,299 pounds. The forces that we enter into MD Solids will be these two forces, not this 1,500 pounds. Next, what about the grid spacing? Well, if we do a little bit of work on this, you'll notice that this angle is always the same as this angle and this angle, which means this is essentially a straight line. That means this angle, or this distance, and this distance are always the same. That means this distance, and this distance are always the same. And since there are 3 legs that all have to be the same length, and my total length is 8 feet, this distance has to be 8 divided by 3. And if you divide 8 divided by 3, you get 2.6667 feet. That's the number we'll enter for our y dimension. And there will be 3 spaces in each direction. Now we're ready to go to MD Solids. Sometimes you have to do a little bit of pre-processing before you start working with the computer. Now we can go to MD Solids. Click on trusses. I'm going to select new truss. And I'm going to set my horizontal spacing equal to 4 feet. And there will be 3 of those spaces. And I will set my vertical spacing to 2.66667, and there will also be 3 of those spaces. And you can see I now have a new grid. So let's go and create members. I'll start down in the bottom. Again, I drag and drop each member. Going to drag and drop 2 members here, and then I'm going to look at my diagram and realize, oh no, I made a mistake. These last 2 members that I drew in are pointing the wrong way. What do I do with those? Very simple. I click on Erase Members and I redraw those two members as if I was drawing over them with whiteout. Now I go back to create, and I can insert the members correctly. That is what my truss should look like. Next, let's create some supports. I create a pin. Now, it might start out oriented the wrong way. Don't worry about that, because when I add the next pin, it'll flip to the right orientation, and my supports are now correct. Now let's add those last two loads, 750 in the X direction and 1299 in the Y direction. Now my truss is complete. I've got the pin in the right place. I've got the loads. These are equivalent to a 1,500 pound load at 60 degrees. And if this looks like a straight line at 33.69 degrees, but it's really, and notice 2.667, 5.333, and 8. So all my spacing is correct. I can now compute. Oh, what happened? Let's take a look. Okay, I'll make another mistake. Let's do this. When I get a message like that, it means these three pieces really should not be three pieces. They should be one piece. So I'm going to go back and erase, 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 and I'm going to create a single member. The load stay the same, the spacing stays the same, the supports stay the same. Now I can compute. And that is how you build this truss. And that's our final answer.